Today's video starts on page 14. It's a problem of the day. Give the number of square units in each figure. Find your answer and cross out the letters above it. When you finish, the answer to the title question, what does a tuba call its father, will remain. So go ahead and pause the video and do this page. Next page, area of parallelograms. Figure ABCD is a parallelogram with base BC and height AX. A height is the perpendicular distance from one base to its opposite parallel base. So base BC and AD, that perpendicular 90 degrees distance from A down to its opposite base would be the height, AX. Triangle ABX, so you can make a parallelogram into a rectangle by cutting off this piece over here on the left and moving it over here to the right, and then you have a parallelogram looking exactly like a rectangle. So it goes through and it tells you that yes, the area of a parallelogram is base times height. Finding the area of this parallelogram, we have a base of 8, don't include this little dotted piece here, and a height of 4. So formula, area equals base times height, that goes first. As you can see here, I wrote number 1, write the formula. Substitute in the numbers, 8 times 4, and then multiply and make sure there's a label on it. So formula, plug in, answer, label is what I say. So 8 times 4 is 32 centimeters squared. Figure ABCD is a parallelogram. There are 2 pairs of parallel sides. That's what makes it a parallelogram. AB is parallel to DC. These little V's in the side are saying that they are parallel to each other, matching V's. So AB has 2, CD has 2. AD, a single V here, is parallel to BC. Draw a parallelogram on this Cartesian plane with an area of 40 square units. Well, area equals base times height. So what numbers multiply to give me 40 square units? Well, I could make an 8 by 5, or I could make a 20 by 2 would be 40, or I could make a 10 by 4, or a 1 by 40, which would be very hard to draw. Draw a parallelogram with an area of 40 square units. So I'm going to draw an 8 by 5. Let's use a straight edge, please, doing this. So I'm going to say the base is 5. 1, 2, 3, 4, 5. And its height would be 8. Is that 8? Maybe that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So, and then a base of 5, or a side of 5, another base, and then the side, the height here, the height, 1, no, not that, no, oh, come on, recognize the pen, there we go, the height here, 1, 2, 3, 4, 5, 6, 7, 8, yes, I got that right. So, this is a base of 5 and a height of 8. I could have also drawn it with the base of 8. 1, 2, 3, 4, 5, 6, 7, 8. And a height of 5. So 1, 2, 3, 4, 5. Let's say it's there. Whoops, that's off just a tiny bit. Let's connect that better. I could have drawn it this way as well. So here's my base of 8 and my height of 5. 1, 2, 3, 4, 5. Yes, I did get that. Right? So there's either way 8 by 5. You could draw, if you want, a 20 by 2 or a 4 by 10. Parallelogram with vertices of -6 and 7, 5, 7, 10, 0, and -1, 0. So we're drawing this. Okay, so my parallelogram, let's see. So negative 6, 6, 1, 2, 3, 4, 5, 6, 7. So there, I'm going to call it A. I like to have vertices on here. So I'm going to call that A. This is B. 5, 7. 5, 7 would be right here. That's B. C is 10, 0. Okay, there's 10, thank goodness. 10, 0, so that's nice that they drew that on there. And D is negative 1, 0. So, should use a straight edge here. So I'm going to use a straight edge using my line tool. I'm going to draw that in. So please use a straight edge or a ruler, as you would call it if you had a ruler, or some kind of straight edge. So this was D. Let's find the area of this parallelogram. Area equals base times height. That base is 11, from 10 down to negative 1 is 11. And this height would be 1, 2, 3, 4, 5, 6, 7. So from a vertice down, perpendicular down to its opposite base, that would be 7. So 11 times 7 is 77 units squared. Formula, plug in, answer, label. The area of irregular figures. One way to estimate the area of an irregular figure is to find the mean of the inner measure and the outer measure of the figure. Kind of like what they did to figure out what pi was. Archimedes circumscribed a circle and inscribed polygons inside and outside a circle. The inner measure is the number of whole squares within the figure. The outer measure is the number of squares touching the figure anywhere plus the number of whole squares within the figure. Estimate the area of this irregular figure. The inner measures are marked with dots. There's 68 of them. The outer measure are the squares that you can barely see there. It's kind of shaded. Is 110. So if you take their average, 68 plus 110 divided by 2, you get 89 square units. An estimate of the area of this irregular figure is 89 square units. Estimate the area of each figure. Well, I've already counted these, and outside there's approximately 89 squares, and inside there's approximately 48 squares. You can see I put all the dots on them. 89 plus 48 divided by 2. So the estimation would be 137 divided by 2, which is approximately 68 and a half units squared. Another way that you can do it is to estimate approximately a rectangle that goes around it. Here's another way. This is pretty close. If I do that, I get that the area of that rectangle is about 14 by 1, 2, 3, 4, 5, 6, 7, 14 by 7. So that would be pretty close to about 98 units squared. Now I know some of them are outside and some of them are inside, but that's pretty close. Another way to estimate irregular figures. And that's it for today's video.